The James Webb Space Telescope is one of the most important things that people have ever done. It is a powerful telescope that looks into the universe and reveals secrets that we don't fully understand yet. This amazing tool has already found things that are so strange and unexpected that they make us question what we thought we knew and make scientists rethink how the universe came to be. Could the past of astronomy one day be broken down into before Webb and after Webb periods? It is becoming more and more likely. The picture we have of the universe is truly amazing. About 13.8 billion years ago, there was a huge explosion called the Big Bang that released the universe from a single, infinitely dense point. As space grew, matter cooled, and the first fundamental forces formed. These forces are what galaxies, stars, and planets are made of. This big start made the building blocks from which everything, including us, was made. But trying to figure out how the world came to be doesn't just help us understand science better. It also makes us think deeply about life and our place in the big picture. Theories try to explain the secrets of this early moment, but our observations are still limited because the universe is expanding so quickly. The James Webb Space Telescope was carefully made to look into the early universe, just seconds after the Big Bang, in order to find out more about this very distant past. It has already found puzzles that even astronomers don't understand. Newly found old galaxies make us question what we thought we knew. Astronomers used to think that these early galaxies would have easier, rounded, or disc shapes that we see today. But Webb's pictures show something amazing. These very early galaxies look long and strangely shaped, like bananas. Webb's careful studies of thousands of these new galaxies could completely change the way we think about how galaxies form, grow, and change over time. These results also shed new light on the mysterious qualities of dark matter, which is thought to make up most of the universe. The discoveries made by the James Webb Telescope don't just turn our ideas on their heads. They invite us on an exciting trip of discovery where cosmic secrets await those who are brave enough to seek them out. What makes these results even more interesting is that some people don't agree with them. Astronomers have seen strange things like this before with the Hubble telescope, which led them to think that galaxies might be made like pickles. Dr. Alan Dressler of Carnegie Observatories, who was a key figure in the development of Webb, has expressed doubt about these findings, pointing out how hard it is to get accurate measurements of galaxies that are far away and faint. However, a statistical study of these galaxies shows something very interesting. Many of them don't look like disks or rounds as would be expected. Instead, they look like long cigars or bananas. The study's lead author, Dr. P.A., goes into more detail about this strangeness, pointing out that many of these galaxies have bright groups set up like pearls on a cosmic string. In the universe we live in now, these long shapes are very rare, but they make up about 80% of the early galaxies Webb studied. This strange event makes me think that our own Milky Way may have gone through similar stages of evolution, changing from a long or surfboard-shaped shape to the way it is now. Edwin Hubble came up with a way to divide galaxies into clear groups in 1926. These groups were elliptical, circular, and spiral. By the time Hubble started to make observations in the 2000s, astronomers had made a thorough list of galaxy shapes from the beginning of time to the present day using data from the Hubble Space Telescope. Surprisingly, what they found was that galaxies were very different 6 billion years ago, with strange forms ruling the universe. It looked like these strange galaxies slowly changed into the spiral shapes we see today over the last 6 billion years. This change probably happened a lot of times when galaxies merged, a cosmic dance that went on longer than was thought before. With the James Webb Space Telescope, we can now study the universe in a whole new way. Its findings call into question the idea that galaxies formed slowly over time from hydrogen and helium clouds in the beginning. Instead, it shows that many early galaxies changed into complicated shapes, like spirals, much faster than was thought. Webb's findings show that about 1/5 of galaxies that are 11.5 billion years old, only 2 billion years after the Big Bang, are already spirals. Because of how quickly these forms changed, it's possible that they weren't just made by collisions. The universe has kept its secrets for a long time, but Webb's tools let us see farther than ever before. This amazing telescope has found galaxies with interesting features and made us think deeply about what we know about the world. Could the universe be a lot older than we thought? One idea is that our world is just one link in a very long chain. It might even not have a real beginning. Some scientists are now looking into the thought of conformal cyclic cosmology, which says that the universe has been born and died many times. Dr. Roger Penrose, winner of the Nobel Prize, thinks that black holes from a long time ago evaporated and caused the next Big Bang. This is a very good answer for the strange, supermassive black holes that Webb's images show. The James Webb Space Telescope is changing the course of cosmic history by breaking record after record. For example, it found the most distant galaxy protocluster, red supergiant, and quasar that had ever been seen. These new findings make me think that the world may be much older than I thought. Webb's findings give us a taste of the endless possibilities as we think about whether our universe is eternal or part of a complex web of universes that are all linked to each other. It's possible that the Big Bang wasn't so much a single beginning as it was a turning point in a universe that will always be changing. Without a doubt, the James Webb Space Telescope, JWST, has changed the way we think about the universe and brought to light questions that were once just philosophical thoughts. Astronomers and cosmologists have been following the Big Bang theory for many years. It gave them a clear picture of how the universe's past fit together. This model says that the universe began about 13.8 billion years ago as a point that was infinitely hot and dense. It then cooled over time, creating the galaxies, stars, and planets we see today. But Webb's finds are making us question these ideas. They show us a universe that is much more complicated and maybe even much older than we thought. The most amazing thing about Webb is that it is very sensitive to infrared light. Hubble's best wavelengths are ultraviolet and visible. Webb's infrared sensors, on the other hand, let it see through clouds of interstellar dust and pick up the faintest signs from the beginning of the universe. This gives JWST a chance to look further back in time than ever before. It can catch glimpses of what the universe looked like just a few 100 million years after the Big Bang. But instead of proving our present models right, these glimpses have shown us strange things that weren't there before. Webb's pictures of galaxies show that they are bigger, more organized, and appear much earlier than what current models say they should be. It looks like whole galaxies formed very quickly right after the universe started. One of the most surprising things Webb found is that spiral galaxies were already fully formed and developed at a time when the universe should have just started. Most people think that because the universe was forming so quickly, young galaxies in the beginning would have forms that were not regular or organized. Webb's observations, on the other hand, have frequently shown galaxies that look like spiral and elliptical galaxies today, without any signs of the violent processes that should have shaped them. Scientists have had to rethink long-held beliefs about galaxy evolution after finding these mature structures in a universe that is thought to be very young. These kinds of findings have led to the idea that the universe may have gone through fast stages of evolution that we still don't fully understand. Some scientists think that dark matter, a mysterious material that is thought to make up a big part of the universe's mass, may have been a big part of how quickly everything changed. Only its gravitational pull can be used to find dark matter. It could have been used as a scaffold to shape galaxies and clusters at very high speeds. Even though this theory makes a lot of sense, it raises new questions about what dark matter is and whether it could explain how quickly these early galaxies formed. But the riddles don't end when galaxies form. Webb has also found interesting things about black holes, especially giant black holes that are found at the centers of old galaxies. Given how young the universe was when these black holes formed, they look much bigger than they should be. In theory, black holes get bigger over time by gathering more matter. However, Webb has found supermassive black holes in the early universe that don't follow this idea of slow growth. How could buildings that big come together so quickly? Some scientists think that these old black holes might be leftovers from a different world, or the result of processes we haven't fully figured out yet. Conformal cyclic cosmology, CCC, which is backed by Nobel Prize winner Roger Penrose, is a radical idea that is getting support. According to CCC, our universe is just one in a long line of eons. At the end of each eon, there is a new Big Bang that creates a new universe. If this model is correct, it means that some structures, like supermassive black holes, might make it through the change between worlds, sending data or energy from one cycle to the next. Webb's findings of very old, very large black holes give CCC some interesting, if not solid, support. Recently discovered by Webb, these results also call into question the popular theory of cosmic inflation, which says the universe grew very quickly right after the Big Bang. Scientists think that this time of inflation smoothed out the universe, making it a more uniform place for galaxies and other structures to form later. Webb's observations of galaxies that were surprisingly mature, on the other hand, seem to go against this time of smooth, uniform expansion. Some researchers now wonder if inflation really happened the way we think it did, or if there are other processes that could explain how the world is structured now. The new information about how the early world was put together also brings up larger philosophical questions. Could the world be both infinite in age and infinite in size? According to current ideas, time began with the Big Bang. However, Webb's findings suggest that the universe may not have a clear beginning or end. The steady-state model says that the world is eternal and always making new things. This idea fits with that idea, even though mostly ignored. With Webb's results in favor of the Big Bang model, the steady-state theory might need to be looked at again. The findings have also led to the idea of a multiverse, which is a group of universes existing alongside our own, each with its own set of laws of physics and history of the universe. The finds made by the James Webb Space Telescope are pushing the limits of what we know about physics. This has led some theorists to say that our universe might not be the only one out there. This multiverse theory says that things happening in our universe might be affected by things or events happening in nearby universes. Even though it's just a guess, this kind of idea might help explain some of the differences between Webb's results and the models we already have of the universe. Of course, not all scientists are ready to give up on old ways of thinking about the universe just yet. Some people say that the strange things found in Webb's data could be explained in a more normal way, like by making changes to the standard model of astronomy or how we think about dark matter and dark energy. Others say that the sudden growth of young galaxies might be due to observational errors or unknown astrophysical processes. Astronomers are still looking over Webb's data to see if these results really do need a new model of the universe, or if they can be fit with the ones that are already out there. But one thing that can't be argued with is that the James Webb Space Telescope has changed the way we study the world. Because it can look farther and clearer than any other tool, we are only just beginning to scratch the surface of what's out there. Webb is changing the way we think about time, space, and even reality itself with every new finding. Scientists and regular people are both very interested in it now. It has made us wonder again about the universe and our place in it. The telescope's ongoing mission promises even more discoveries that could make our knowledge of the universe even less stable. We will keep using Webb to look for the first stars and galaxies, make maps of how planetary systems form, and study the atmospheres of exoplanets in the hopes of finding proof of life beyond Earth. Each of these interests has the ability to change how we think about the history of the universe and our place in it. The James Webb Space Telescope is like a time machine and a detective in many ways. It lets us see what happened in the past huge amounts of time and figure out how it all fits together. As it continues its journey, it asks people to join the search, to question everything they thought they knew, and to be open to the idea that our universe and maybe even our very existence are part of a much bigger and stranger cosmic fabric than they can imagine. What do you think? Are we really at the start of a new era of knowledge, or is the world getting ready to reveal even bigger secret? Leave your thoughts in the comments, and let's keep looking into space together.